All right, hello everyone. Thank you for showing up for this edition of the SRE Cross-Training. Today we will be talking about metrics, service level indicators, service level objectives, service level agreements, and accompanying ideas, thoughts, and procedures. Hopefully I'll be able to keep it fairly entertaining. It's normally a pretty dry and boring subject. So hopefully I can keep your interest. Please do feel free to interrupt me as I'm talking. Go ahead, throw up a hand, and I will take a pause to answer any questions. And I guess with that, let's get to it. Paradise found. Why we care about metrics. So a little while ago, I found out that paradise actually translates to walled garden. And I thought that was a really cool bit of information, and started thinking about, production networks. And a production network is very much a walled garden. We've got all the security around the sides. So anything that comes into the production network, we are intentionally bringing in, or at least I hope we're intentionally bringing it in. And therefore, I feel sort of naturally the metaphor of the gardener becomes what we are as SRE, is that we are the gardeners attempting to keep the walled garden as beautiful as possible, making it into the paradise for our users to enjoy, for ourselves to enjoy. And this takes a lot of work. We both need to ensure that the plants that we want to be there are growing, healthy and strong, but also we need to pull out the weeds. Um, so obviously, I've just gone through most of the ideas on this slide. However, in addition to being the nurturing, caring gardeners that help the plants and the systems grow and become better, beautiful, strong, healthy, we've also got to come down like a ton of bricks on any sort of disruption that comes into the garden. We do not want the weeds in the garden of paradise. We do not want the disruption in our beautiful place that we're in. And so not only are we the gardeners, but we're also the gatekeepers. Within the Western canon, there is the great walled garden, the great paradise, the Garden of Eden. So most of the time when I'm thinking about this particular metaphor, I think of us as the avenging angels, right? When something that we don't like comes into our walled garden, we come down on flaming wings with our swords on fire in order to purge the weeds from our network, to remove unnecessary services, to get rid of bugs within the code. This is what we're pretty much all about. Be not afraid. SRE is here. However, today is May 4th, so I've decided to go with a Star Wars theme because Jedi also have flaming swords. Therefore, I've taken a very tenuous connection and decided to run with Star Wars today. So, health. SRE fundamentally only cares about one question. Is the network healthy? Is our system healthy? Right? We don't care if it's improving. We don't care what else is happening. Is the service healthy? Are our users able to use our services as they're supposed to be able to? That's all we care about, honestly. So again, throwing back to the gardening metaphor, is our garden weed free? Are we bug free? Are all of our machines up and running? Are our services growing well? Are we getting the patches in that we need? Are we introducing safe, stable new features to the network? This is how we keep our garden healthy. This is how we keep our paradise beautiful. So now that we know that this is what we want to keep our garden healthy. I mean, how do we keep it healthy? Well, obviously we have to look at it, right? There's no way to know what is happening unless we actually observe it. So while we're observing it, sometimes measurements are not that important. They can be approximations. If I say move the table, a finger's length from the wall. I've got 4 fingers that are all slightly different sizes. We've all got different size fingers on our hands, but a finger's length is a good abstract model of a measurement to be able to use. Um, and so, we could say, we could use these abstract, imprecise measurements within the network to say, that's pretty good. It it the machine responded within a couple of seconds. That's fine. But this isn't really good enough to be able to keep a long-term process and understanding of the health of our network over time. Um, there are many measurements that we can take. We could do things like measure how high a server is off the floor. We could take a look at the network traffic. We can take a look at the number of requests. And some of these measurements are more important than others, right? It might be actually useful to know how high up off the floor a particular server is, but in day-to-day operations, not so much. So as we're talking about metrics, we need to start talking about standardization. We all want to be using the same comparison model, right? If I'm saying it's 1 finger's length away from the wall and my finger's a different size than your finger, we don't actually have an agreement on how far away from the wall the table is. So, in the science community, we've got the SI measurements. Importantly, using the same measurement um, or not using the same measurement caused the NASA Mars Climate Orbiter to crash because of a translation bug between metric measurement and US standard measurement. And because of that bug, NASA lost, a robot sitting around Mars, and that's not great. So meaningful metrics that we care about should be meaningful. Um, server temperature can be meaningful, but not always, particularly appropriate to what we're talking about. Disk spin speed could be important, but we we have tons and tons of different metrics that we could measure. And as I said, some of them are more important than others. Some few actually give us an idea of how healthy our machines are. And of course, accuracy. A metric is only as useful as it is accurate, which is why we don't use, finger length as a way to measure things as they come out. We get a measuring stick, we say it's 4 centimeters or whatever, and then we can all have an equal understanding of what it is. It's it's a meaningful measure of distance from the wall to the table, and it's an accurate measurement because we can all go back and understand exactly how far the table is from the wall in this example. So critical metrics. The critical metrics are the ones that actually give us an idea of what's going on. If there is 100% CPU usage, we know that the machine is busy. That's generally the critical metric. If memory is full, that can be important critical metric. But depending on the machine itself, these may not actually be the critical metrics. For a web server, latency is very important. For an AI training job, latency is fundamentally meaningless. If I'm getting results back tomorrow, if it takes an extra 5 minutes, that really doesn't mean anything. So for different services, our critical metrics are going to be different. For a web server, latency, throughput, number of the hits per second, but versus a worker machine, which has an entirely different set of needs. How fast does it spin up? Does it crash? How quickly does it get to through the iterations and be able to produce the output? Does it have the memory available or the GPU memory available to run particular simulations? These are the critical metrics, and they're different, as I said, for each of the services. These critical metrics we pare down into a handful of truly, this handful of metrics are the ones that we can look at and say, this machine is okay at the moment, or this machine is not okay at the moment. These become our service level indicators, right? We don't care about most of the other metrics, as long as these indicators are good, the system is presumed to be good. If one of the indicators goes bad, we can use all the other metrics to understand what's gone wrong with the system, but we don't generally need to track and alert on these secondary, less important metrics. Right. So combined view of reading the metrics gives a state of the health of the system, giving us our service level indicators. Our service level objectives. So now that we understand what we need to look at in order to determine the health of the system, we must determine what those indicators look like in order to proclaim that the system is healthy, right? For a web server, it could be, you know, that we are getting under 2,000 hits per second. It could be that we are sitting at under 60% CPU, whatever that indicator happens to be, we set our thresholds. Often it'll be a higher threshold, sometimes it's a lower threshold, sometimes it's a upper and lower bound. And this will be very specific to an individual service because each service, although they will share universal standardized metrics between systems, what's important for one server or one service is not going to be the same for another service. Uh, disk access speed is much more important for a database than it ever will be for a web server. Right. So once we've set that threshold, these become our targets, and we must remember that these should be practical, right? We should be able to hit them. 99.9% uptime is a beautiful, wonderful idea, but it's actually very hard to hit in reality. So setting the expectation, setting it reasonably, setting it to something that we can actually achieve, that's very important. And we can always change it later. Service level agreements. So now that we've got our indicators, now that we've got our objectives, the agreement is over a set period of time, a set time window from, be it, a month, a quarter, half a year, a year. We now have to prove that we can keep our objectives to the agreed upon level of healthiness for that set period of time. And as part of the agreement, we get to understand, well, what happens if we succeed? I mean, where's our carrot for doing the work? Where's our carrot for actually getting stuff done? What happens if we fail? I mean, how much less carrot do we get? I'm specifically avoiding carrot versus stick here because you should never use stick on a human. Just shouldn't happen. I mean, you shouldn't use it on animals either. But punishment does not motivate the people as well as potential rewards. So how much carrot do you need to be offering to ensure that you are going to make these agreements, right? For a company, if you hit your agreements, you get paid a certain amount. If you don't hit your levels, you're going to get less money out of the process. So it's lots of carrot or little carrot, and these are what the agreements tell us to do. And very importantly, this is not a sliding window because we are set at an objective that from May 1st to May 31st, we will have a 95% uptime on whatever system. If we have this as a sliding window, this becomes a unreasonably hard or potentially impossible goal to meet. Moving the goalposts makes our jobs harder. So we must ensure that our SLAs are set for a specific period of time, so that way we can do all of our planning around ensuring that we hit these goals for that certain period of time. Static versus dynamic. So a perfectly reliable system will never change, right? That's fundamentally, a misunderstanding of what SRE is actually about. If we want an actual reliable network, we would never allow it to change. We would fix everything and we would lock it in concrete and never let anything do anything to it. And then we would know it would work, it would always work, and we would have a perfectly reliable system. However, that's boring, right? Nobody wants to be working on a system that doesn't change. And our users are going to want new features. The developers are going to introduce new features. We're going to want to upgrade various bits of the network. And so we must introduce change. And change is where error comes in, right? Every time we make a change to the network, there is a potential for a new error. There's a potential for a new disaster. Um, all progress is change. All change is inevitable, and entropy is not on our side. Even if we don't allow any sort of software updates, we're still going to have to be dealing with entropy. Hard drives going bad, memory going bad, CPUs burning out, power cords frying, network switches going down. So change is actually required in order to maintain reliability. Bringing us to the idea of error budgets. The SLI, the SLO, the SLA, these are all about keeping the network healthy. And keeping the network healthy means keeping errors to a minimum, which means keeping change to a minimum, right? It's not about improving the network. The SLI, SLO, SLA is not about improving the network. It's not about improving the system. It's not about improving anything. It's about setting a target for health and staying there. However, that's boring. Why would anybody want to work on a system like that? So the concept of error budgets gets introduced into the whole agreement structure, and this is risks that we're going to take, risks that we want to take. We want to court disaster. We want to take these risks. We want change. We want to introduce the possibility of error because that's how we get new plants, how we make the system more beautiful, how we how we remove dead plants and bring in new stuff. Change is important. It's inevitable, and it's fundamentally it's the fun part of the job. Um, However, we must be careful with our error budgets. We want to be spending our error budgets intelligently. We want to be taking intentional risk by changing the networks at a set, controlled manner, right? We want intelligent risks. We want to ensure that the risks that we're taking are, within our error budget. We want to ensure that we're spending our error budget, wisely. Um, this is why we have testing. This is why we have test environments. This is why we have staging environments. This is why we do like replays of real network activity on potential new replacements. This is why we do burn-ins, because we want all of the errors that we can find to be mitigated before we bring it onto the production network. For instance, before you plant a new plant in your garden, you will often check in to make sure that it doesn't have any sort of parasites on it that can then get into the system and destroy your other plants, right? You don't want it to have fungus on it. You want to make sure that the new plant that you're planting is healthy in the first place before you even allow it into the walled garden. I hope any of this is making any sort of sense. So obviously, change is valuable, right? This is exactly where we want to be. We want to be in an active, dynamic environment, but we want to be adding new features. We want to be doing bug fixes, changing services. We want to embrace change. We want to embrace the chaos. We want to surf that wave of chaos that's coming our way beautifully, so that you know it's a new, dynamic, beautiful environment, but it's changing over time. We've got little construction signs in certain places, and so that's where we get to SRE as change management, right? How many errors are we going to allow? What errors are we going to allow? What errors are we going to discourage? Mistakes absolutely happen. Mistakes are not something that can be totally mitigated, but we must learn from them. Failure is inevitable. You know, entropy is the great obstacle. Servers will die. Failure is inevitable. No matter how much we prepare, there will be mistakes. There will be equipment failures. There will be somebody kicked a network cable out of a port by accident. Right. This stuff just happens. Right. And the law of large numbers, which Murphy is a semi-restatement of, is that given enough time, anything that can happen will happen. So as change managers, what we try and do is we try to limit the number of things that can go wrong, and actually the number of things that can go super right, because what we're really seeking is a stable, predictable network. We want to have an understanding of, if I do this, the rest of the network will do the same thing. It's not super useful for us to have like super like successes. A particular machine you know um, uh, responds in half the time, 5% of the time, right? That's not super useful. Stable, predictable network processes are what we're actually interested in, because that's reliable. We can understand that, we can predict it, and we can work around it. So risk mitigation, right? While taking risks is necessary, we do have to introduce change. We do have to, swap out machines. We do have to upgrade switches. We must take our action to mitigate as many errors as possible, right? Schedule downtime. If we schedule downtime, then all the errors that happen while we're doing the upgrade, they don't count. Testing and staging networks, as I previously mentioned, are other good ways to make sure that the systems and bugs that we're bringing in are bug free. And this takes a lot of preventative measures, right? And so SRE is very focused on preventing disaster, because preventing a disaster is better than recovering from it. I would rather not have to wake up at 2 a.m. fixing a computer than to have to wake up 2 a.m. and be able to fix it very quickly. There's really no question between the two in my own mind. So disaster prevention, the disaster that we disallow to happen is, of course, the best kind. That's why we have build policies. That's why we have particular push policies. And this is why the policies that we have in place must be meaningful, and they must be precise, and they must also be minimal. Because the more policy and procedures that we have in place, the more frustrated devs get, right? The more frustrated we get with doing our jobs. And so policies and procedures must continually be growing. And like bad servers and bad bugs, we must also weed out bad policies. If the policy does not help the production network maintain health and to be able to change and evolve in a healthy way, that policy is getting in the way and must be removed, right? Um, Particularly policies that are just busy work. That doesn't help any sort of work to be done, and just causes frustration, and frustration, causes distraction. Distraction causes errors. So policies minimal, policies meaningful, policies precise. Disaster recovery. Obviously, no matter how good we are, we cannot prevent all disasters. So disaster recovery becomes a very important part, calling back to the SLAs and the SLOs, because the faster we can recover from a disaster, the better we can maintain our health targets, right? And so, the first thing that we want to do when we come across a disaster is fix it, right? We don't want to be investigating what happened. We want to fix it first. Then, when we've got the time to breathe, we can go back and see what happened. We bring a new plant into the garden. The plant starts to wither. The plants around that starts to wither. So we just rip it all out, replace it with new healthy plants. Then afterward, we go take a look at the plant to find out what happened. Root rot, some sort of parasite, whatever it happens to be. But only after the system is working again, only after the garden is once again beautiful. You don't, as the old adage goes. I mean, if you've got water spilling all over the floor, you turn off the water before you start mopping up, because if you start mopping up while the water's still going, you're never ever going to be able to get ahead. So mitigate, then investigate. Very important. And of course, this leads us to the postmortem. Postmortem, again, very important, um, because once we've made a mistake, we want to ensure that we don't repeat it. We learn from our actions, we learn from our failures, we learn failures are inevitable. We learn from it. Mistakes are inevitable. We learn from it. We try to ensure that in the future we don't make the same mistake, and we try and ensure in the future that we don't succumb to the same failure set. Right? I mean, because I think right. So after the postmortem, after we talk about it, we've just discovered the root cause. We've discussed ways to prevent it from happening again. Some things like disk failures are unavoidable. Bad memory is unavoidable. Network issues are unavoidable. So when we start talking about that, we can start talking about things like mean time to failure, ensuring that we replace our hardware before it fails, and taking proactive steps to avert disaster. And this is SRE. SRE, in opposition to some sort of more general DevOps, is the prevention of disaster in opposition to being master firefighters. Right? We don't want to be firefighters. We want to be fire preventers. So of course we update our policy set, and then also we can look at the past policies and see if any of the past policies actually contributed to a new disaster. If we've got a past policy that says we only swap out disks every 3 years, and we're seeing disks die after 2 years, that old policy has to go away, has to be replaced with something like replace disks after like a year and 8 months, whatever it happens to be. But these policies must be dynamic, and they must change, and they must grow the same as everything else in order to ensure that they are still applicable and accurate and meaningful for the current situation. Hopefully, I haven't bored everybody to tears. May the fourth be with you. Any questions? And I'm going to go ahead and stop the recording now.